Greetings, welcome back. We are in session 7, predictive modeling and basically evaluation. That's the relatively large presentation, larger slide, number of slides. And part 6 was about support vector machine. I think that would be a little bit too advanced for us, so I did not discuss that at this stage. I will try to simplify and discuss that in future. At this time, I would like to go and talk about part 7, which is simple. We have spoken of regression in the past quite extensively, specifically when it was referring to linear regression. So this picture, I hope you remember, this is the line. So you do have some results, blue and red. They could be actually across the 2D space anyway. If you wanted to take a look at that, just to refresh your memory about what we have discussed in the past, you have a number of sample data points. So these are your sample data points. You want to find a line that is going to be passing through the data, and the error, accumulative error of the data points corresponding to the line is going to be minimum. So if you shift this line a little higher, the error at the bottom is going to increase, the error at the top is going to decrease. If you shift this a little bit down, the impact is going to be reversed. So you can't just go down or you can't just go up, you just have to stay in the middle, right? So what is happening is that we are going to calculate all of these error terms. And when we calculate all of them, we take them to the power of 2. We are going to sum them up, and then we are going to take a square root. And the idea is that we want to have the least mean square error. So that's what we want to do. We want the minimum to be, we want the error to be a minimum. And this line, of course, has a number of parameters. It has a slope, as you can imagine. It is going to be starting from potentially an initial point. And if you know this initial point and you know the slope, you know the line. So we are going to review this in the slide in a moment. And that's going to be our linear regression. The linear regression is going to be mainly on the numerical points. And then we have something called logistic regression. The logistic regression is a simple classification based on, for example, nominal outcome. So you have X1 and X2 and X3. They are coming into the system, and you're going to see whether it's going to be a happy penguin or a sad penguin. So that's what we are going to do. If you take a look at this, this slide, at some point, I'm going to have this curve, and this curve is going to be similar to a step function to me. Anything basically below a threshold, I'm going to declare them sad. Anything above a threshold, I'm going to declare them happy. One thing I needed to remind you, we discussed that in one of the labs extensively and one of the recordings in the past. The linear regression is helping us to find a trend. So we would say that if I have any missing data, how can I actually interpolate and find that missing data? Hopefully, the trend in the future is going to be the same. So as the x-axis is increasing, you would be able to actually extrapolate or predict what the future is going to look like. As soon as you know the line, everything becomes quite simple to do. Keep in mind that not all least square error is going to yield you a linear response. Of course, if you take a look at this one, it is a nonlinear relationship. You can potentially see that the data points are not moving along the line of a linear line. So if you say this is going to be a line, a linear line, you're going to introduce a lot of error. But of course, if you wanted to minimize that, one option is to go, for example, parabola. You could increase the degree of the function from first degree to second degree to third degree and so on, and it's going to help you to capture the error and minimize the error. So let's review this. Again, this is not something new. We have extensively discussed them in the past. In linear regression, the data are modeled to fit a straight line. For instance, the random variable is called target variable, can be modeled as a linear function of another random variable, which is x in this case. It's going to be a starting point. If x is 0, your y is going to be b. So as you remember from the graph we have spoken of, this is going to be my b, and this is going to be my slope. If I happen to have my b, the constant, and I know the slope, then I know the line. So that's going to be quite helpful for us to move ahead with the interpolation, extrapolation. We could potentially have multiple linear regressions. It's called similar to piecewise linear approach. If you take a look at this one, I could say that the error could be minimized by a straight line here. So that's a straight line. Do you see this? Then I could say that the error is going to be here, minimized, and then the error here is going to be minimized, a straight line again. You could do that if you divide the data into different sets and basically capture the variable behavior. Once again, this is a relatively simple formula, and we have the least square error function discussed in the past. Logistic regression is going to help us to actually capture the binary classes, I would say, yes and no, happy and sad. It's going to be relatively easy to do so. That's going to be a regression techniques for us to keep in mind, and that's a very brief explanation of